Welcome to qnawire.
Hi, so over here we're asked to calculate the potential of the cell at 362 Kelvin for the following composition. We're given the value for E0 for the cell and the concentrations of Ag plus and copper 2 plus. Remember that Nernst equation, what it's going to tell us is that the potential of the cell would be equal to the standard potential minus RT divided by NF natural logarithm of Q. So, in this case, the temperature is going to change. The value for the Faraday constant is going to be equal to 96,500 coulombs per mole. A comment over here, this is the value that most of the professors employ for the value for Faraday constants for most of the calculations. The actual value is going to be 96,485.33 coulombs per mole. But you can replace the actual value for your calculation depending on what your professor is employing as Faraday's constant value. Okay, so with this information, we can calculate directly the value for E. The value for Q, the coefficient of concentrations, would be equal, looking at this reaction, to the concentration of copper 2 plus divided by the concentration of silver plus squared. So, for that reason, our potential is going to be equal to the standard potential, 0.464 volts, minus R, 8.314 joule per mole Kelvin, multiplied by the temperature, which is 362 Kelvin, over, and in this case, we're going to have an exchange of two electrons, as you can see over here on the balanced reaction, times the Faraday's constant. Here I'm going to do the calculations in with the simplified value of the rounded up value of 96,500 coulombs per mole times the logarithm of Q. And the logarithm of Q would be concentration of copper 2 plus 8.15 times 10 to the minus 4 over 2.93 times 10 to the minus 3 squared. So with this, our value for the potential would be equal to 0.393 volts, which is this option over here. And with that, it would be all. Thank you very much and have a good one.